Section 2.1, Relations and Functions. A relation is a mapping or pairing of input values with output values. Think of coordinates. The set of input values is the domain. That means what are all the x values, the inputs that can go into a function, and that's the domain. And the set of output values is the range. What are all the y values? What are all the results that come from this function? A relation is a function provided, that means when there is exactly one output for each input. It means you can only have one and only one output if you want to say this is a function. The domain is the input, and the range is the output. Now you can have one input and get one output. You could also have a many-to-one relationship. So that means you can have many x values or many inputs, and they can have the same y value. But what you can't have is many outputs. You can't have 0 for x and get -2 and -5 and 6. You can't have many outputs. You can't have an x value getting you lots of different answers. You can have many x values getting you the same y, or you can have a single x giving you only one y, but you can't have many answers coming out, many outputs coming out of the same, of one x. So x value repeats. This means that when you have, here as in number 3, 2, 3, so when you put 2 into the function, you get 3. And when you get 2 in the function, you get 4. And when you get 2 in the function, you get 5. So you have a vertical line here. This is not a function because you're getting multiple outputs for the same input of 2. So if you have the same x value repeating itself and getting different outputs for y or f of x, then this is not a function. Another way to check whether it's not a function is by mapping it. So here in number 1, you can see 1 goes to 2, 4 goes to both 5 and -5, and 2 goes to 0. So because 4 has 2 different outputs it could get, then this is not a function. However, as we said, you can have many-to-one relationships. You can have many inputs that still get you the same output. And that is still a function. Yes, function. So one-to-one and many-to-one are okay, but one-to-many is not. So here, another way is to graph it and do vertical line tests. We'll go through number 4 first. So let's plot these points, 3, -1, 4, -1, and 5, -1. So what we have is different x values getting you the same y value. And that's okay. That's this many-to-one. So that is a function. And this function would be something like f of x equals -1, at least for this domain right here of those three x values. Versus this is x equals 2. You're not putting a function into it. X is just always 2 and nothing's ever changing to it, so not a function. The last check, number 3, is the vertical line test. So when you have a graph and you want to see if it's a function, if you can draw a vertical line and if it crosses the graph twice, then it's not a function. But here you can see it only crosses once. Wherever you put it, you can put multiple lines through it just to double check. You can see it only crosses once for each line. So these are good. This is a function. Yes. Now, if you put a vertical line on here, you'll see that this crosses y values twice. Up top and on the bottom of this ellipse. So this is not a function. Because there are multiple y values for the same x. Many functions can be represented by an equation in two variables, such as y equals 2x minus 7, and we will write this as f of x equals 2x minus 7. So it is good to remember that when you see f of x, it's almost like saying it's another name for y. When you used to see in slope-intercept form y equals mx plus b, here we have f of x equals mx plus b. An ordered pair x comma y or x comma f of x is a solution of the equation. In an equation, the input variable is called the independent variable. So what we're saying is when we put a value for x in there, an x value, let's say we put the number 1 in there, that's our input. And when it varies, when it's a variable, it's called an independent variable. You might have seen this in science classes. Independent variables are the things we change, and the output or dependent variable is what results or what happens after we put it in. The independent variable, this x, is the domain. The domain of the entire function is all the values of x that we're putting in. The output variable is called the dependent variable. So the dependent variable would be f of x, which is that other name for y. So y or f of x will change as you change x. The graph of an equation in two variables is a collection of all the points x, comma y, whose coordinates are solutions of the equation. I'm going to put in that this, just remember, is a little bit like y. And the dependent variable depends on x. So here we want to try to, for number 7, put in values for x and see what we get for f of x. So what is the input would be whatever number we replace x with, and the output is the result, and we would just replace f of x with what that number is, that result. So function notation is where we say, what is f of x when you have an x value of, for example, -3. So here, the function is f of x, that represents what's the output. And this says, what is f of x when x is -3? And so the output would be 2 times -3 plus 1, which equals -5. And the ordered pair in function notation would be x comma f of x. So here what we're saying is when you get -3, you get a value for the function of -3. And when you write it numerically, as in just numbers, you get -3 comma -5. So we can go through these. F of -2 is 2 times -2 plus 1, which is -3. Ordered pair function, -2 comma f of -2. And the ordered pair numerically is -2 and -3. We can graph these. We can start -3, -5 would be down here. -2, -3. So we can see a slope of 2 already, and that matches what we expect with this slope, up 2 over 1. And we're expecting to see an intercept at about 1 because it's in slope-intercept form. So we should see it cross right here at that red dot I just put on the graph. So let's keep going and seeing what happens. If we put -1 for x, what is f of x? 2 times -1, which is -2, plus 1 equals -1. The ordered pair is -1, f of -1, and numerically it's -1, -1, right here. And here we have 0. What is f of x when x is 0? 2 times 0 plus 1 equals 1. This is just like when you're finding the y-intercept. You put a 0 in for x. 0, 1. Oh, f of 0. And then numerically would be 0, 1. And that crosses exactly where we expected it to. F of 1 is 2 times 1 plus 1, which is 3. In function notation, the ordered pair is 1 comma f of 1. What is the function after you put 1 inside? What's the result, the output? 1, and you get 3. And if you have the function with 2, 2 times 2 plus 1 equals 5. And so the ordered pair would be 2 comma function of 2, and then numerically 2 comma 5. F of 3 is 2 times 3 plus 1, which equals 7. Ordered pair is 3, f of 3, 3 comma 7. 3, 7, 2, 5, 1, 3. You get a nice line going through it all. Now we've graphed it. For number 8, similar. We can graph number 8 for this one is called g of x. So the function's name is g of x, which is also the same as what we said before. When you have it's just saying it's a different function. Sometimes you'd use g of x to distinguish between f of x and another function, g of x. And so here we'd maybe begin graphing with a -1, 0, and 2. Let's see what happens with these numbers as we plug them in to the function g of x. We get -1 plus 1 equals 0. So our coordinates are -1, 0. For 0, it's 0 plus 1, which equals 1. So the coordinate would be 0, 1. And for 2, it would be 2 plus 1 equals 3. Coordinates of 2, 3. So this makes sense because the slope is 1 and the intercept, the y-intercept, is 0, 1, which is actually what we got in our function when we plugged 0 in. So it's exactly what we expect to see. Exactly what we expect to see. We use function notation so that we can be more descriptive in real-life modeling problems. So when you think about this problem here, David works at the t-shirt shack selling tees. The equation P of x equals 15x minus 520 represents the profit that the t-shirt shack makes for each t-shirt sold, where P of x is the total profit and x is the number of t-shirts sold. Answer the questions and graph the function to the right. So we're trying to figure out the relationship between profit, how much David's making, and how many t-shirts he's selling. So P of x, which is y, is the total profit, and x is the number of t-shirts sold. So that's good to remember that. Think of this as y. And it's also the dependent variable, depends on x, whatever you put x in to the equation. And this is the independent variable. Independent, we can put in different values for x. And you notice right here, minus 520 in the function. That means, and that makes sense, and that means that we're going to have to sell a lot of t-shirts before we start getting a positive profit. And that makes sense because in the normal business world, you're going to have machinery and equipment, or materials at least, and maybe rental fees to use that equipment to sew those t-shirts together. And that's your initial cost to enter this business before you can actually make money. So you've got to make sure you sell enough to make it worth it. So the domain, remember, is all the x values, all the x values that can go in. So it's the number of t-shirts. The domain is t-shirts, which could be not negative, but it's because it's in a real life situation, it's going to be 0 to infinity. Describe the range. The range is the profit, how much money you're going to make. And we know that we could not sell any, and it might go from a minus, a loss. So this is our P of X, which is minus 520 up to infinity, depending on how much we sell. And what does P of 5 mean? That's your profit when you sell 5 t-shirts. And so as evaluate, that means plug it in and see what you get. Give us that input of 5, and what is P of X at 5? So P of 5 equals 15 times 5 minus 520, which is negative 445. So write a sentence describing P of 5. So what happened? We have sold 5 t-shirts which isn't enough to earn a positive profit. We are still $445 in the hole. So let's see. If you wanted to graph this graph over on the right wouldn't fit these large numbers, these large losses we're taking. So let's put 0 in for x, and we know we'd get negative 520. If we put in 5, we'd get negative 445. If we put in 1, we would get negative 505. And so I would make maybe my own graph to help illustrate to somebody what's going on with our company. And I would say, okay, here is, if we sell 0, we start at negative 520 in the hole. Got 0 here. If we can sell 1, then I'll make this a little longer. If we can sell 1, then we'll be still minus 505. And if we can sell 5, we'll still be at minus 445. So we have 5, negative 445. So we've got a long climb ahead of us to sell enough t-shirts to get into the positive profit area.